Our last look at rational expressions is going to be in the form of what we call a complex fraction. Now, this is basically saying that the fraction by itself has a rational expression in the numerator and or the denominator. And so these particular type of rational expressions can look very intimidating to simplify at first. So there's a couple ways to go about doing this, and what you're going to need to do is find the way that works best for you. Now, we offer two methods in this first example of a complex fraction, and you can read through both of them, and I'm going to make my recommendation as to the way I do it, what I find to be simplest. But really, in the end, whatever works best for you is what's important, that you get to the final answer correctly. So I'm not really concerned if you do it different than I do. Now, we've got a couple things going on here. Since we, for the most part, have a rational expression in both the numerator and the denominator, my preference is simply to simplify each rational expression as if it were its own problem. So basically, I look at it as two completely separate problems, and I simplify both the numerator and the denominator as far as I can go. And then, if you keep in mind, and I'll just use these examples up here on top, if you keep in mind, the division bar here is the same thing as saying this: x plus 3 over 2 divided by 2 over x minus 4. So those are basically saying the same thing right there. And so what I would simply do is, to make this work, I would go ahead and get the common denominators, and I would simplify rational expressions right off the bat, and then I would change it to a division problem. So if we go down to example number 2, you can see that we give you two methods here to simplify the same problem. Now, for me personally, I kind of enjoy method number 2 better, and you can see in method number 2 there's simplification in the numerator, and then there's simplification in the denominator separately of each other, and then as we come down, we just simply change it to a division problem, which then we can flip it to a reciprocal and make it a multiplication problem, and then go ahead and simplify the problem just like you did when you were multiplying and dividing rational expressions. So don't let the look of these initially give you any problems. Don't let them intimidate you. Just treat them as almost two completely separate problems. So go ahead and move on to sample number 4. And we've given you kind of a nice straightforward one to start to get some practice. And then, of course, the ones on Math Excel will probably become a little bit more complex. No pun intended. All right, go ahead and try sample problem number 4 and come back and watch the solution. Now, generally speaking, a complex fraction would have probably a rational expression in the numerator and a rational expression in the denominator. However, this one is a little bit more straightforward because the numerator is just a polynomial by itself. So I really only have to simplify the denominator first, and then once I'm able to do that, then go ahead and convert it to a multiplication problem. So I'll go ahead and work on that now. Okay, and you can see here that I've gone ahead and created a common denominator for the bottom rational expression, and now I'm going to go ahead and combine those into one part. Now, technically what we've got here is a division problem with that bar, so if I could just say x divided by y plus x over xy, and that would simply become a multiplication problem, and I'll flip the second part and finish this problem. and that would be our reduced complex fraction. Alright, so that one was pretty straightforward. Each complex fraction kind of has its own issues that you have to deal with, but if you think of it as two separate problems, I think that you'll come out okay with that one. Alright.